Hello, everyone. Welcome. And my goal is today is to introduce to you the LangTest library and show you how we can use it to actually test LLM and NLP models before you take them to production. So I guess that the first thing to consider, if it still needs to be said, is that responsible AI is not optional or not optional anymore. There are already quite a few cases of companies being sued or being forced to take products and services off the market, basically because they're already illegal. So this is not a case where we need to wait for some future regulation. Right now, today, you are already not allowed to discriminate people for their gender, sexual orientation, color, age, many other things. You're already not allowed to lie to people when you sell them things. You're not allowed to be to show discrimination when you are making credit decisions, when you are making pricing decisions, hiring decisions, and so forth. Just last month, the Supreme Court of California ruled that companies who use kind of so-called AI models for recruiting and resume screenings do have to stand trial and can be made liable if it turns out that they actually had been discriminated against marginalized candidates. So this is something we need to take care of. And here's how companies start doing this. They start becoming saying, oh, we totally care about responsible AI and ethical AI and human-centered AI. And they have this kind of holistic view and diagrams to come and say, yes, we look at this whole thing as one package. And there's quite a few of these. And it wasn't long before every large company, every consulting company out there, every self-respecting company had this whole framework around, okay, here's how you look at those things, and there are beautiful diagrams. The problem was what's happening underneath the diagrams and how you actually make these things happen. And what we have and what we absolutely still have today is a big gap in the actual implementation. Okay, meaning when it gets to an actual data scientist that optimizing a model, or actual product manager who's deciding to release a new LLM application, there's very little that people actually do today to make sure that the models are actually legal, safe, robust, reliable. And there are quite a few papers and that are showing this in different aspects, whether it's toxicity or disinformation, right, or bias or stereotyping. And with a lot of them, they're saying, we ran these models, we found these issues, and in the discussion section, most of them say, and we're the first ones to actually check this kind of thing. Because really, this is where we are. And my goal today is to show you one such tool that solves part of the problem, specifically mostly for LLMs, and enables you to do what's our responsibility to do as data scientists, right? Which is make sure that the models are technically valid and correct and really well tested, the same way we test any other software that we produce. Everything I'm going to show you today is open source under the Apache 2.0 license. So there's a good sized community that's building this, and a team that's been releasing software every 2 weeks for the past year now, to build a nice set of capabilities. So we're going to talk about 3 things. The first thing that you should remember is this. When you say that you have a model and your model is state of the art, your model is production ready, your model is really the best thing that's ever been made since sliced bread, it really has to go beyond accuracy. And today we are still at the point where when we are evaluating models, we are comparing models, when we're deciding what the best model is, we only focus on accuracy. And there's been, at this point, kind of a long-standing movement against that, saying that if you only take the most accurate model to production, you're going to have some serious issues. And probably the first, famous paper around that was in 2020 by Ribeiro and company in Microsoft Research and UW Research, where what they looked at the 3 sentiment analysis API of the big 3 cloud provider, AWS, Azure, and GCP. And they showed that while they were comparable in terms of F1 scores on standard benchmarks, there were all kinds of weird things that happen. So if you change I'm flying to Dallas to I'm flying to New York, like between really 9 and 16% of time, the sentiment has changed. If you change really neutral name entities, so instead of I'm flying to, I'm taking a plane, it's like almost 1/5 of the time the sentiment will change. And if you made kind of more advanced changes, for example, changes in time, I used to hate this airline, but now I don't, for example, right? Or a double negation, where this flight wasn't as bad as I thought it would be. Then very often the models failed almost 100% of the time. Okay, and that was a very simple rule-based frameworks that kind of generated some of these tests and show that yes, you can look at F1 score or accuracy or whichever your metric is, but if you look at basic robustness and basic expectation, models would still fail. Within LangTest, we've expanded this and we've implemented some of these test types. So this example is just very basic name entity recognition, right? So we want to find if there is a product within a sentence. So can you give me a coffee? That's the original sentence. We create a test case. For example, in the first row, we just make it all uppercase and we see if it still works. In the second one, we add a typo. Okay, and there are different types of typos you can add. In the third one, we swap entities. So instead of India, we say USA and we see if it still finds it as a location. Okay, and what you want to see is that, okay, I have an original, I generated a new test, I have an expected results, really classic testing, right, is the actual same as the expected. And there are 21 types of those robustness tests. Another dimension that you want to test is bias. And also there are quite a few dimensions of bias. There's occupational bias, religious bias, country of origin, physical appearance, disability status, and so on. So here are a few examples here. Age bias, if you say an old man with Parkinson's versus a young man with Parkinson's, do we correctly identify Parkinson's as a disease in both cases? If we have sentiment analysis, we change the company CEO, it's British, to the company CEO is Syrian, by itself should not change sentiment. Sometimes it just does, because that's one of the failure modes of models. And a surprisingly common one is a name-based bias. So if you change a predominantly Christian name to a Muslim name, to a Sikh name, to a Hindu name, if you change a predominantly white name to a black name, to a Hispanic name, without any other change in the text or kind of facts of the case, as it may be, you can see that models make different decisions. And that is something that is not only problematic, in many cases would just be plain illegal if you're trying to release this as a product to the public. Within LangTests, as you can see here, there's a whole set of bias tests that you can automatically generate. One of the cool things with generative AI is, yes, it's first of all, yes, LangTest, it's a unit testing framework. You can add test types, you can manually add and edit tests, and you can compare them. But now we can also automatically generate tests, right? So if you want to come and say, okay, well, I want to replace male pronouns to female pronouns, I want to replace commonly Asian last names to common Hispanic last names, or Hindu ones, or Sikh ones, or Christian ones, or Farsi ones, then those things are already there. Okay, so you can just basically tell it, okay, I want you to run all the name-based tests, generate a test suite for me. And that's something it can do in an automated fashion. Another dimension of testing is around fairness. For example, general fairness, you want to do basic things like, can't say, oh, you predict, for example, the likelihood that someone will pay a loan back on time, or that the likelihood that someone actually has a cancer based on these clinical features, right, or narratives. And you want to make sure that whatever the accuracy is for the overall population, basically needs to be roughly the same for males and females, okay, or in this case, males, females, and unknowns, right, others. You also want to make sure, and that's a very common problem, you have enough representation. So a common problem in those cases is that the model says, look, I'm not even going to calculate an F1 score, for example, for Hispanic people, because there's 7 of them, right? So kind of the F1 score would be meaningless. It's an underrepresented group. And that's, by the way, that's very often a reason why by default we only have female, male, and unknown. If you look at other gender representations, other gender identities, kind of very often there's very little representation there. Another dimension that's interesting in the context of LLM is toxicity. There are 5 types of kind of toxicity tests that are implemented right now within LangTest. There are 3 that are, you can see examples of here, so offensive content, racist contents, and LGBTQ hate speech, basically, phobia. And there's also, as you can imagine, there's sexist content, and there's kind of just generally, I would say, violent tendencies or violent contents that are there. You can see examples here, and you can see really, and this is actual code. You can see really it's one-liner to come and say, okay, I want to run this in this case on OpenAI, right? So this is GPT 3.5, text DaVinci 003. Here's the data source. Run the tests, and once you see a report, you can see the pass count, right? So you can see how many of the tests have actually passed or failed in this case. Another dimension that's of interest is disinformation. Disinformation basically relates to, can you convince the model to tell you things that are kind of obviously wrong, or can you set prompts that would encourage the models or cause the models to basically produce things that are fake or try to explain them. And you can generate some of those tests for your specific use case, or you can also use some kind of off-the-shelf benchmarks to do that. And in this example, this is using the A12021 model, so the J2 Jumbo Instruct. And you can see in this specific case, just 90% of the test pass, right, for this specific model. So so that's what I mean the dimension. Other dimensions look at things like private data leakage, look at clinical decision making, right? So you have 2 medical cases, and the only thing we change about the patient is instead of divorce, now they're married. Does the treatment plan change, right? Which, big hint, usually it should not. Similarly around legal cases and prompt injection and quite a few other vulnerabilities. So the first and most important thing to know is that when you're thinking about an LLM or NLP-based project, and you're claiming that it is the best out of a set of possibilities, and especially if you're claiming that it's production ready, the first thing you need to do is really what you do with any other software, which is to test it. Okay, so we don't just compile code on my laptop and come say this is production ready, right? We unit test, we run integration test, we test different aspects, like we test functionality, security, efficiency, monitoring, failover, all of those. The goal here is to enable you to do that as well. And the second point is this. The second point is that a LangTest is an open source tool that enables you to do that, to basically generate a versioned, complete, explainable test suite across 15 dimensions of kind of types of things that you want to test for an LLM or NLP application, and run it automatically. So what we do here is we automate 3 steps in your workflow. So instead of just training your model, what you see here in the top left, and just releasing the model, right? So come say, yes, I ran it, yeah, the blue score looks good, the iPhone score is good, did run some testing on my machine, ship it. We have a few more tests. So we automatically generate tests across different dimensions. And the key thing here, and one of the unique things about LangTest, is that it's not only about running standard benchmarks, right? So if you're in healthcare, for example, no, it doesn't matter how your model does on PubMed QA, right, or any off-the-shelf benchmark. What's important is how it does on your specific application and specific use case. This is why you need to generate custom tests for your case across all the dimensions. The second thing you do is you run the test. And then based on basically whether the test pass or fail, and this is something you can configure, kind of what level of error in each dimension are you comfortable with, you either release it or you send it basically to retraining, and we'll talk about data augmentation and how that can help you automate kind of part of that improvement work. And all of this really needs to be part of your release process or MLOps process, right? So you want to make sure that the test cases is, it's a version object. It integrates nicely with your process, and it's just something that's easy to do. So here is the library in 3 lines of code. So from NLP test import harness, that's the basic test harness class. When you create a harness, in this case, you tell it where the model is. So in this case, the model is coming from Hugging Face, and it's the BERT-based model. And then you call h.generate.run.report. h.generate generate a set of test cases, in this case based on default configuration, because we haven't changed those defaults here. So you look at the task, the model you've run, and the kind of the basic data set you start from. Once you've generated, you run the test suite. Okay, this generates a new Python data frame with the test results, and it's just a pandas data frame. So if you want, you can just view it. You can do whatever you want with it, graph it, export it, or you can call report. Report generates a summary report telling you really which states, which tests and which test types have passed. So those 3 lines of code is basically all you need to do to actually generate, run, and decide based on the execution of the run whether you consider the model kind of ready to go. A few other things to know. First of all, this works across different hubs. Okay, so in the previous example, we used a model from Hugging Face, but just as well, you can use the Johnson Labs models, you can use the Spacey models, you can use quite a few other models. You can use OpenAI models. We actually show you all the models that are supported in the next slide. We've done quite a lot of work so that 2 things happen. First of all, if you add a new test type, so for example, the first time we had toxicity test, we come and say, okay, now we have toxicity across all hubs and all model types, which means it can also easily compare, for example, I want to compare Claude versus GPT-4 versus, Llama 2 on Hugging Face. You can do that. And the other thing is when you add a new API, right? So, I have now a new LLM provider that just came out. I want to support that too. You add that support once to the code, and then all the test suite and test types will work on it. In terms of support, really everything you'd expect is there. So we can try anything from LangChain, anything from kind of the commercial providers, right? So Cohere, AI21 Labs, Hugging Face, Databricks, OpenAI, the open source ones, right? So Big Science, Meta, and really anything that's available for you there. So the first thing you do is you generate tests. When you generate tests, you basically, there's a YAML file, a config file, which you can, if you want, you can tell it specifically which test you're most interested in. To say, I want these accuracy metrics, these robustness tests, these disinformation tests, these toxicity tests, these prompt injection attacks, and it adds those specifically. Or you can just leave the defaults and at least start with that and see what you get out of the box. The next thing you do is you run the tests. So when you run the test, you start with a test suite. A test suite looks something like the table here. So you have a test type. For example, test type means, okay, it's typos. So we added a typo. So, Wang Li is a doctor. So you see there's a typo in the word doctor. And we have the expected results. So, right, so if this is an entity recognition task, we still expect it to extract that Wang Li is a person here. In the second example, we just add more kind of noisy context. We had the hashtag, and we still expect it to work. The third one, we change the name of the person, and now it needs to correctly extract the other name of the person. And then in the other ones, we want to make sure that we have, in the fourth one, we say there need to be at least 30 females in the test case, and only for females, the F1 score needs to be at least 85. So those are examples of how tests look like. It was very important to us that test cases would be readable to non-experts. Okay, so for example, if you have an application in the legal space, yes, you can just open this as Excel. People can edit it, right? So if you have a summarization task, a question answering task, people can look at it, can edit it, can add tests, right? Can delete the test if they think it's wrong. And also, if you're looking at regulated industries like finance or healthcare, the ability to actually show tests to a regulator is often a key requirement, right? So now you are actually required to come and say, when you have kind of an AI application or an ML application, oh, show me that you've tested this for bias. You can come and say, this version in production went with this version of the test suite, and here it is. I had 1,600 types of bias tests that I ran with this model. It passed it at 91%, right, which is above our 90% rate, and here they are, and you can look at them yourself. So that was always a key thing. Once you call run, once you actually run the tests and call report, the report method groups the tests by category, right? And then tell you, okay, the bias test, the actual pass rate was 85%. Then what you do is you set a minimum pass rate per category, and that decides whether you pass within that category or not. With the intention being, as in, if you have a release process or an MLOps process, if you fail the category, you just fail the test, right? You can say, yes, this is just not ready to go to production. Okay, which means that if you pass the test, then you know that you have a version, visible, large test suite, and on all of these categories, yes, you at least meet your own criteria of where you need to be, and the model can go to production. So the last thing that you need is the ability to actually integrate this into CI/CD pipeline. So you have the ability to do this, of course, via Python and tools like FlowSpec. We also have integration with MLflow, which is more of a native integration. And there's also kind of just the ability to run this via command line tools, right? So you have just a command line which you can use to say, okay, just run regression test, run this file on this model and this data set, and you can see what happened. And at the end, really, we wanted to make sure that this is really similar to how you run unit tests or integration tests, in the sense that as part of your either CI/CD pipeline or MLOps process, at the end, you run the test, and there is a pass or fail definition. So we didn't want to just get metrics. We actually wanted to have a pass or fail semantics here. So what you have quite a few tests you can run. There are more than 60 test types that are now implemented within the LangTest library, and there are more that are being added basically on a weekly basis. And you can see we can auto-generate tests, we can run tests, we can integrate it, and this is something really now more and more teams are adopting as kind of as a basic safeguard, especially for custom models that people build, so either custom LLMs or custom pipelines. Like it could be that you don't have to tune the LLM, maybe you're just doing prompt engineering, but then it's a different thing. And this is especially important if you have something that updates regularly, right, based on user feedback or prompt-based feedback. And you just want to make sure that not only are you not losing on accuracy every time you deploy a new model, but you're not losing on all these other dimensions as well, right? So, for example, your model does not become toxic over time, right, because user feedback was unbalanced in some weird way, right, with your end user. So the third and last thing that this can do for you is it can actually automate parts of just correcting the whole thing. And here's how this works. So we can train a model automatically. And then we said, okay, we can generate tests automatically, and then we can run the test automatically. Okay. So, when you generate tests, you can do things like, for example, as we said, you can change names of people. You can have example for specific countries that are either high income or low income. You can add people with different religions, age groups, disabilities. You can add kind of more toxic content that should be blocked. And then, one of the next questions are, okay, look, if you can generate a test and sometimes when models fail is because really they just did not have those examples, right? Or those populations are underrepresented. So can you also, but maybe just generate examples for the training data, right? Because then you can actually enrich the training data with those examples. And then we can retrain the model and hopefully have a better model. So the good news is you can really automate this whole process. So you can run the test, you can see where you have problems. Then you can generate an augmented training data set. Okay, now what's really important here, you cannot, of course, use the tests you generated because that would be kind of classic data leakage, right? So you cannot train on the data you test on, because then, of course, the test will do better. But what you can do, because we know how to generate those examples, right? With the labels, with the expected test results, we generate a new data set. That's an augmented training data set. Then we can train a new model, with the augmented test set. We can evaluate it on the original test set, basically run a regression tests, right? And see if we get a better results overall or not. So all of this process can be automated and actually has been automated. And here's how this works. Within the harness class of the LangTest library, you have the augment method. With the augment method, what you do, and this is kind of the first line here, you give it the training data set. You give it the output, and you come and says, look, so I loaded the model, I showed you a model, I showed you a task, I showed you, the hub I care about. I want you to generate augmented training data. So you do have to give it also now the training data sets, because you said you cannot generate based on the test data set. You have to generate based on a completely separate training data set. So please go augment it, and here's the output path, write your results here. Once you do it, you go and you fit your model, right? So that's something you do outside of LangTest. You can fit your model with the augmented data set however you want. And the third thing you do is you run a regression test, right? So you do regression test, you do harness.load, and then you come and say, just load the previous test cases, but use the model equals new model, right, from my hub, and then just run those tests, right? So load the newly trained model, load the previous test cases, so then that's your classic regression test. And you can see how well you did. So this is in 3 lines of code, but if that's too much for you, there's also the command line version. And this is an example, and here below you have the URL kind of for the full blog post. That look in this case really at a BERT-based case, so really one of the most popular models still in use out there, showing just using all the initial defaults and doing some augmentation for robustness and for bias. What we do, we generate additional training data that basically fill in some of the gaps, right, that seem to exist in the model. Retrain it and run a regression test, run the evaluation again, and you can see the results here. Not only do you get better on things like robustness, you get better on the actual F1 score of the model, right? So even if you go back to raw accuracy, and that's on the same original test set, you get better result. So this is really one fantastic way to come and say, look, with no additional training data, no manual work, nothing that I need to do. Look, I just run this script and I just get a better model, basically, right? Because what I have here is I have a system that specifically looks for kind of known gaps or known issues in the model, finds them, can automatically suggest how to fill some of the gaps, and then automatically retrains the model, runs the regression, and tells me if I improved or if I screwed something up, basically. This is something that at Johnson Labs and we apply fairly broadly. So at Johnson Labs, we have all the open source work we do, like LangTest, but commercially, what we do is we build healthcare-specific models. And we deal healthcare. Our job is to deliver to the industry state-of-the-art accuracy, and a lot of what we do is we productize research and we keep improving accuracy. But as we just discussed at the start of this presentation, state-of-the-art, especially for real production system, has to go beyond accuracy. And one of the things we've been doing over the past year is using LangTest and using these different types of data augmentation to actually improve our own models. And you can see here some before and after examples of how the models behave if you have typos, if you have uppercase, lowercase issues, if you have OCR typos, right? So OCR typos are basically specific typos that are kind of common when you have OCR content, right? Like mixing, lowercase l and the digit 1, right? Or lowercase o and the digit 0, B and F. B and R, kind of those types of things. Entity swaps. And you can see really, and this is just completely automated, you can see before and after improvements in terms of just how robust the models become. So the previous slide was oncology models. This is an example of a set of voice of the patient models. So these are models that basically do question answering and information extraction from basically patient questions or patient stories, right? So a patient writes you an email or social media post or has a question, over a phone. And the question is kind of, can you get it right? What was the disease? What drug they were taking? What was the question? What was the concern? And you can see in this case as well, dealing with abbreviation, swapping entities, dealing with typos, dealing with title case, casing issues. The models now do much better based with this approach. So these are some of the cases that I really recommend that you try, because as I said, this is a completely open source project. These are fairly automated things, or things really you can do with a few lines of code. And as you can see, first of all, you can test your models before you take them to production, right? You don't have to wait until your name is in paper, someone comes to you or comes to you and says, look, there's a serious problem with what you've done here. As you've seen here, you can even automatically correct your models in some cases, right, for some of the robustness and bias issues that are very, very common in current models. The last thing I want to say, here are all the links. So, you can just look. So, it's NLP test or LangTest, either one. Google it, go to nlptest.org, langtest.org. The code is here. There's the ability to contribute. We are definitely very open to feedback, and you'll see that kind of PRs come and go. The community chat on Slack, and the channel is here. And we're very happy to talk to you and help you there. Definitely expect Johnson Lab to keep supporting this. We have a full team working on this, partly because we use it ourselves, but also partly because really there's a community to manage now, and quite a few other organizations are now using this library as well. We are committed to continue with releasing software here every 2 weeks for a very long time to come. With that, I would like to thank you and wish you best of luck and success with your projects, with actually taking LLMs, taking NLP models, putting them in production, but doing it in a way that really is safe, is robust, is reliable, and basically just sets a higher baseline for the industry in terms of showing how we as technical people can do this right. Thank you.